a simple linear regression. First, we have to take a look at where our data come from. Here's a data file with advertising expenses and the yield in terms of the millions of dollars that are received. You'll notice these don't look like they line up. That's because there are tab characters there. If you can see that, it's a single space character between Miller Lite and the 50.1 and 32.1. We just adjust the tab size to anything we want. It's just a display. And we want to read those into R. Read.delim is the function that will read delimited, tab delimited data. You can get help in R. And it shows you the data, the help file for this. So you just have delim, and the default here is that there is a header. If we look back at that file, the first line is the names of the three different variables here: the firm, the advertising expenses, and the advertising yield. So we read those into an object in R called advertising. And there's our data. We also see that it showed up over here in our studio in the environment. Well, the first thing we want to do whenever we're working with some sort of a relationship between two variables, plotting the two against each other. Notice how this works. The data structure advertising has these three fields in it: firm, advertising expenses millions, and advertising yield millions. The syntax in R is the object and then a $sign to the field. So this advertising $, advertising yield millions refers to this field here. That's the expenses, the yield is in this field right here. And so that's the Y variable, our dependent variable. And this tilde is an easy way of displaying between it. Once again, we can always get help on the plot command, and it tells us all about how that works. There's a couple of ways that you can do it. We could plot the X variable and then the Y variable together, or we could use the syntax that I've used here, which uses a tilde between them, which says the Y variable tilde the X variable. You can do it either way. So we run that, and there's our plot. And for example, we can see that our Miller Lite had a yield of 32 million with an expense of 50 million. So 50 million, 32 million. So one of these dots right here, for example. Another firm that spent about 50 million and got about 30 million. Let's just see if we see that offhand just by eyeballing the data. Right here, Wendy's spent 49.7, yielded 29.2. Okay. Well, let's do a linear regression on this. So this LM function works with the same syntax that I've used for plots. One of the reasons I use the plot with that tilde function in it. So LM is going to give us a linear model for modeling yield against expenses. And we see it comes back with something that's not, it's just a simple summary of a linear regression line. And we can just go ahead and plot that using AB line. AB line is A and B are the intercept and the slope of a line. There's a couple of different ways you can use the AB line, but it will take a plot that already exists and adds a lot to the display. And there we are. There's our linear regression line. Now we might want more information about our linear model than simply the model coefficients themselves, and that's all you get if you say LM and then the model that you're trying to fit. Instead, what you want to do is store this into an object. And then you can do various things on it. You can get the summary of that. Excuse me. Just using autocomplete there, using the tab character. Now we've got a lot more information about the statistics of these. Here's the intercept and the slope of this line, but more importantly, we also now have the statistical test, and we can see that the slope is in fact significant, which makes sense when we look at the data. It does appear to be some sort of a linear trend. Maybe there's nonlinear effects going on here, but overall, if you spend more on the advertising, you do yield more. So that goes there. We also see our R squared is about 40%, so about 40% of the variability in our yield was explained by the effect of expenses. So there's a simple linear regression example for us.